there! It's time to do some systems of equations. Chapter 7.1, we're on page 279. Follow with me. So a system of equations is really easy. It's just saying if I have a line coming one way and a line coming the other way, where do they intersect? What point is on both lines? So let me show you. Over here, we have a line in blue. It says y equals negative x minus 2. And then we have a line in green. It says y equals positive x minus 4. So where do they intersect? Let's find out. So I got me blue, okay? Y equals negative x minus 2. You notice the slope right here is a negative 1. We could rewrite that as y equals like a negative 1 over 1 minus 2, right? Negative 1 over 1 is the same thing as a negative 1, which is just like our negative x. And we need that because we need to find our slope. So we're going to go down 1, and over to the right 1, right? So we're going to start, here's my slope, negative 1 over 1. This is my y-intercept at negative 2. Let's find out where that's going to be. So starting at negative 2 on my axis, right here. Drop a big old fatty dot right there. And I'm going to go down 1 over 1. So I'm going to go down 1 here, over 1 there, put another big old fatty dot. I'm going to draw my blue line straight through there. Okay, you guys with me? You guys can do this. Okay, then we're going to go ahead and look at my green line. My green line, where's it going to intersect it? Well, let's look at this. This is my y-intercept, the negative 4. It's going to hit here at negative 4. And then my slope here is just 1. It's really 1 over 1, right? 1 over 1 is the fraction in front. There's no number right there, so there's technically a 1, and 1's the same thing as 1 over 1. Just like over here when I had a negative, there's no number. It's negative 1. And so it's like negative 1 over 1. So that's where I got that, and that's where I got that. So let's say we start here at negative 4. So we're going to start at negative 4. So we go, start at the origin, 1, 2, 3, 4, start at negative 4. Big old fatty green dot. And then I'm going to go down 1, or sorry, positive 1. We go up 1 and over 1. That's what that says. Up 1, over 1. So go up 1, over 1. And you can put another big old fatty dot right on top of that blue dot. You see, my graph is going to look like this. I have my blue line coming down, and I have my green line going up. The blue line goes down because it has a negative slope. The green line goes up because it has a positive slope. You read math like you read a book. So you start at the left-hand side and you sweep over to the right-hand side. Just like you would read a book on a page, then it words on a page like this. So if we're starting here, this blue line goes down because it has a negative slope. This green line goes up as we go to the right because it has a positive slope. And right here, right there is the most important point of the entire graph because it's the point that is on both lines. It's on the blue line and on the green line. You see this point right there. If you go to go, let's find it. If I start at the origin, I go over 1 and I go down 1, 2, 3. Over 1, down 3. This is 1, comma, negative 3. That point is on both lines. I can prove it to you. That's an x value. That 1's an x value. The negative 3 is a y value, right? So if I plug in 1 to my graph, I should be able to get negative 3 out. Let's try it in red. Okay, here we go. So plug in number 1. So if I plug in a number 1 right here, plug in 1. Right? Plug in a 1. If I plug in 1 right there, watch what happens. Oh, I'm okay. Everything's going to be okay. I plug in a 1 right there. That's going to be y equals a negative 1 minus 2, right? My blank, I'm plugging in a 1, but it has a minus out front. A negative 1 minus 2, that's just negative 3. So yes, I plug in a 1, I got out a negative 3. That's proved there. And on this one, if I plug in a 1 right here, I'll get y equals 1 minus 4, which is going to be y equals 1 take away 4 is a negative 3. Again, we plugged in a 1, we got out a negative 3. This is the only point. 1 comma negative 3 is the only point that fits in both lines. See, the blue line and the green line both share that point. It's called a system of equations because you have a system, 2 equations, and they're hitting at the very center point right there, and you're looking for that point. We found it. Hallelujah! Are you guys ready for example number 3? Come with me. Here we go. So, example 3 has blue line right here. X minus y equals negative 5. Well, that's not in slope-intercept form. We can't graph it like that. We've got to make that y equals mx plus b. So let's get y by itself. We're going to subtract x on both sides, which will make this negative y equals negative x minus 5. The x's go away, negative y, put the negative x first, and a minus 5. But I don't want negative y, I want regular y. So I got to divide by a negative. So I'm going to divide everything by a negative. Divide this by a negative, divide that by a negative, divide that by a negative. I'll end up with positive y Let's change the sign there, change the sign here, and change the sign there. When I divide everything by negative, I end up getting that. Let's go ahead and graph that. I have a slope and a y-intercept. My slope is 1. So I have a slope of 1. I have a y-intercept, of 5. That's a terrible 5. Of 5. Let's go ahead and graph that. I'd start at 5, and I'm going to go up 1 and over 1, because technically that's 1 over a 1. So let's try it. So let's start at 5. So start 1, 2, 3, 4, 5. Put a big old fatty blue dot. And then I'm going to go up 1 and over 1. My slope is 1, so I'm going to go up 1 and over 1 and put another big old fatty blue dot. You see, this line is going to go right like that. Perfect. It's positive because it has a positive slope, so as you go from left to right, it's going up. Perfect. And it goes right through 5, slope of 1. Then we're going to deal with green. Dealing with green, I want to solve for y. Because it's not in slope-intercept form, I got to solve for y. I need y equals mx plus b. So subtract 3x from both sides. So minus 3x and minus 3x, I'll end up with y equals negative 3x minus 7. There's my equation. I'm going to start at negative 7 because that's my y-intercept. So let's go like this. Y-intercept is negative 7, and my slope is negative 3. My m is negative 3, or that's really just negative 3 over a 1, right? So let's start at negative 7. Start at negative 7. So 1, 2, 3, 4, 5, 6, 7, and drop a big old fatty dot there, a big old green dot. Then I have a slope of a negative 3 over 1, so I'm going to go down 3 and over 1. I don't even have graph down there. So I got to go down 1, 2, 3, down here, way down here, and then over 1. I'm going to be way over here, right? But I got to connect those dots. These dots have to connect right about there, like that. I drew my line. So now I got to find the point of intersection. That point of intersection solves my system of equations. It solves both of my lines where they're actually going to be touching. I need that point. I'm going to go find it. So let's go ahead and grab it. It's going to be right here. The question is, what point is that? Well, if I start at the origin and I go over to the negative 3 and I go up to the 2, this would be negative 3 comma 2. Let's see if that's right. I got to get my pen. It fell on the ground. I'm back. Okay, so negative 3 comma 2. I got to plug that into my original two lines. I got to plug it into my blue line. I got to plug it into my green line. So it's probably traditionally good to plug it into the original one, not the y-intercept, to plug it into the original one just in case that you made a mistake, but it doesn't make a difference if you do your math correctly. So I'm going to take my red pen right there, and I'm going to plug in my x value is negative 3, and see if I get a y value of 2, see if it works. So if I plug in negative 3 right here, plug in negative 3, so let's do this. Plug in a negative 3 right there. I'll get y equals negative 3 plus 5. What's negative 3 plus 5? It's 2. It works. I'll get 2. I'll get y equals 2. It works. It checks out. That point is on the blue line. But is it on the green line? It has to be on both. We have to check both. So I'm going to plug negative 3 into my green line. Again, you could plug it into this, but it's probably better to plug it into the original. So if I plug negative 3 into the original, let's try the original. It would be 3 times, let's try that, it would be 3 times x, right, plus y equals 7, negative 7, my bad. Let's plug it in. Plug in negative 3 and plug in 2 and see if this is true. So it would be 3 times negative 3 plus 2 is equal to negative 7. 3 times negative 3, that's negative 9, plus 2, is that equal to negative 7? It is! We did it! Yes! We did it! Negative 9 plus 2 is equal to 7. That's the correct point. It's on the green line. It's on the blue line and the green line. It is the only point that is on both lines. We solved our system of equations because we plugged them back into the original and it all worked out. Now, what happens if we would have plugged it in and it didn't work? Because what if I was a terrible grapher and I plugged it in and it didn't work? Like I maybe thought that point was at negative 4 comma 2 or maybe negative 3 comma 1. Like what if I was off by just a little bit? If it doesn't work in both equations, you got the wrong point. It doesn't work. It doesn't work in the two lines, then it doesn't work. It's not a solution. And sometimes you're even going to get two lines that there'll not be a solution. Like what if you got 2 lines, let's go over here, that were 2 lines that were parallel. If you have 2 lines that are parallel, then there aren't any solutions. You'll be plugging in stuff forever. It will never work. You've got to have 2 lines that intersect And you have to find that point. So when you're doing your graphing, be extra careful. Maybe use graph paper. Maybe use a ruler, nice and straight, because it is very helpful to find the point the first time. Otherwise, you'd be checking all over the place, and that's never good. Okay, land it out.